This section of the training discusses match recognize. Match recognize is an SQL standard. It allows pattern matching based on regular expressions. If you are familiar with regular expressions, you know that they specify a search pattern for searching strings. Match recognize also specifies a search pattern and searches a stream of events. Match recognize can be used with data windows and named windows. When an event leaves the data window, the runtime removes partially complete pattern matches that contain the removed event. When using a data window or named window, any matches consists of only those events that are retained by the data window. The idea of match recognize is: define a pattern by using variable names as placeholders for events. For each variable name, placeholder, define a Boolean condition that tests events. We'll go through the syntax of match recognize so you'll better understand the clauses and keywords. The EPL starts with a select clause and a from clause. The from clause, as always, can provide the event type name and optionally a data window, or it can have the name of a named window. After that is the match underscore recognize keyword. After that is a parenthesis. The first clause in match recognize is the partition clause. The partition clause is optional. The partition clause partitions events and matches are within the same partition only. If there is no partition clause, all events belong to the same partition. After that is the measures clause. The measures clause is required and selects from matches. After that is the pattern clause. The pattern clause is required and has the pattern that contains variable names. The pattern clause can also specify alternatives, repetitions, optional matches and nesting. Variables can be understood as placeholders for events. The optional interval keyword can remove partial matches based on time. The define clause is optional. The define clause can provide Boolean expression for each of the variables in the pattern clause. If a variable is undefined, it matches any event. This example analyzes a stream of withdrawal events. The example finds pairs of withdrawal events, for the same account, wherein the first event must have an amount greater than 400, and the second event must have an amount greater than the first amount. Select star from withdrawal. Match recognize. Partition by account. Measures W1.account as account W1.amount as amount 1 W2.amount as amount 2. Pattern parenthesis W1 W2. Define. W1 is W1.amount greater 400. W2 is W2.amount greater W1.amount. The pattern this is looking for is W1 W2. It matches when an event comes in that matches the criteria W1, immediately followed by an event that matches the criteria W2. An event that matches criteria W1 must have amount greater than 400. An event that matches criteria W2 must have an amount greater than W1.amount. We continue the discussion of the match recognize example that was presented on the previous page. The partition was partition by account ID, since the requirement was to find pairs for the same account. The select clause was select star, since the measures clause already selects the fields we want. Assume there was no defined clause. The runtime would output pairs regardless of the value of the amount property of events. Variables can appear repeatedly, for instance. Find 3 withdrawal events with amount greater 400 and immediately following each other. Measures W brackets 0 as first withdrawal. W brackets 1. Amount as second amount. Pattern parenthesis WWW. Define. W as W. Amount greater than 400. Since there are multiple W values, one can use array index to address each event. Say, W brackets 0 for the first event, W brackets 1 to address the second event, W brackets 2 to address the third event. Let's study the pattern clause in more detail. Within the pattern clause of match recognize are the variables. The samples here have a variable name of A, B and C. In the pattern clause, the pipe character is a vertical bar and it means alternative. So, when the pattern reads A, parenthesis B pipe C, the runtime looks for an event that matches the A criteria. Then, either an event that matches the B criteria, or an event that matches the C criteria. In the pattern clause, the star character means 0 or more, greedy. We'll explain greedy later. So, when the pattern reads A, B star C, the runtime looks for an event that matches the A criteria. Then 0, 1 or multiple events that match the B criteria. Then an event that matches the C criteria. In the pattern clause, the plus character means 1 or more, greedy. So, when the pattern reads A, B plus C, the runtime looks for an event that matches the A criteria. Then 1 or multiple events that match the B criteria. Then an event that matches the C criteria. In the pattern clause, the question mark character means 0 or 1, greedy. So, when the pattern reads A, B question mark C, the runtime looks for an event that matches the A criteria. Then 0 or 1 event that matches the B criteria. Then an event that matches the C criteria. In the pattern clause, one can append another question mark character to means reluctant matches as opposed to greedy matches. Reluctant and greedy matter when the criteria overlap and an event can match multiple variables' criteria expressions. For instance, a given event may fulfill both the criteria for B as well as the criteria for C. So, when the pattern reads A, B question mark C, the runtime looks for an event that matches the A criteria. Then 0 or 1 event that matches the B criteria. But if that event also matches C criteria, treating it as a C instead. Then an event that matches the C criteria. Match recognize patterns can have quantifiers that define the number of repetitions. Use the quantifier curly n for exactly n matches. The pattern A curly 2 is equivalent to AA. Use the quantifier curly n comma for n or more matches. The pattern A curly 2 comma B is equivalent to AA plus B. Use the quantifier curly n comma m for between n and m matches. The pattern A curly 2 comma 4b is equivalent to AA a question mark B. Use the quantifier curly comma m for between 0 and m matches. The pattern A curly comma 2b is equivalent to a question mark B. Quantifier can be combined with other quantifiers. For instance, a question mark curly 2 or parenthesis AB curly 2. This slide highlights some of the additional keywords for match recognize. For handling permutations, there is a match recognize permute keyword, and after that keyword is a list of variables. Let's say the variables are A, B and C. The permutation is equivalent to pattern A, B, C or A, C, B or B, A, C and so on. The interval keyword is followed by a time period. It specifies a time to wait for additional matches in a pattern such as A, B star. In terms of match output, by default the runtime ranks matches and outputs only the one match with the earliest event. Please see the documentation for the complete ranking. The all matches Keyword lets the runtime output all matches. In terms of match resumption, by default the runtime resumes pattern matching at the next event after the last event of the current match. The after match skip keyword controls where pattern matching continues after a match. For this slide we picked a use case from a security monitoring software. The security monitoring is looking for events that have an outcome of failure or success. Each event also has an activity value such as modify. It is looking for 5 or more failures and 1 or more successes and then a modify, all of which within 10 minutes. The example selects from event. The value for the outcome event property must be either failure or success. The time window is a time window of 10 minutes. The match recognizes partitions by user, as it is looking for an activity pattern per each user. The measures clause outputs the variable values themselves, by selecting the variables f, s and m. When the pattern matches, the output row has 3 columns. The f column contains an array of failure events. The s column contains an array of success events. The m column contains an array of events with a modify activity.